Hey everyone, welcome to my stream. So a couple nights ago, we were actually getting somewhere pretty interesting, and we'll be continuing on that route tonight. So yeah, let's recap where we were last time. So I made some progress on the vector drawing, but there's still some things not working. Now, where I stopped a couple nights ago, if we go here into the BIOS, I think this is a really good place for us to kind of focus very early on when the Vectrex starts up. It gets to this bit of code here, so if we go up here, start here, it does some kind of first power up loop. This prints the Vectrex power on screen and plays the power on music. Now, the very first thing it actually does in terms of rendering and drawing is it does this display power up message here. So you can see here it sets the intensity, and then it wants to show this vector title, which is basically Vectrex. But this actually is a bit of a pain to debug and all that. So instead, what we'll do is we'll just skip ahead and we'll stop here into the intro boxes, draw the frame boxes. Now what that refers to, I'll show you here. If we look up Vectrex boot up here, this. See these lines here? There's like an inner box and an outer box, right? So in fact, we see here load X intro boxes. If I remember, there are, yeah, you see here, intro boxes is a label that first describes the outer box and then describes the inner box. It also has some patterns for the boundaries, line patterns for boundary boxes. Because you can see there's actually like a stippled pattern here, and they actually move over time. So basically, it's supposed to draw these boxes, right? Now what I did in preparing for the stream is I took just this set of coordinates here, which are, you know, relative, and they start from 0, 0. And let me pull this up, and I just put together this little picture in Paint. So what you see here is, assuming that we're at 0, 0, the first thing it does, and remember that the ordering here is Y and then X. So first it wants to move the beam 64 in Y up here, and then minus 42 in X. Now I converted these to decimal just to help me. So then that means that we should be at minus 4264. Then at that point, I believe it turns on drawing, and then draws from this corner. And you can see here it says don't change the Y, but move 86 units to the right. So that brings us to about here 4464. Then after that, it wants to move down, so minus 127 in Y, but no longer in X, so 0 in X. So this delta movement here goes down this way, bringing us to 44 minus 63. And then after that, don't shift in Y, but move to minus 87 in X. So that's this line here, which should bring us to minus 43, minus 63, which is not quite square, but anyway. And then move up 126 in Y and 0 in X. So that brings us up here, and that gets us pretty much this kind of box shape here. So that's intro boxes, right? So if we go back, yeah. So here you go, draw the frame boxes. So it says move to IXFF. So move to the start of line. So this, I think the deal here is that there's actually two parts to this. As we saw, that the intro box actually starts off with the like initial positioning, right? Then after that are the four movements for actually drawing. So what's gonna happen here is we start by loading into X the first set of coordinates, and then this call is going to take that value in X. I think it sets the, what's FF again? Let's see here. These routines force the scale factor to FF. Okay, that's it. So move as quickly as possible. So if you recall, the scale factor is basically the time in timer 1. So saying make it the fastest possible. And move the pen to the YX position pointed to by the X register. And then the X register is then incremented by 2. So basically the pointer is moved to the next coordinate pair. So yeah, so if we come back, this call here should get us to this location here. After that, we want to draw our 4 lines. So here, you're supposed to put the number of lines you want to draw -1 into A. If you want to use this function, draw pattern pat VLA, which is basically all of these routines draw a series of patterned vectors. The pattern to use must already be specified in C829. So this is the pattern that should be put into the shift register. I think that's what we'll see down here. Store a shift register, put the pattern in the shift register, yeah. And get the default pattern and then vec pattern. So I guess vec pattern here must be C829. Let's see. Yeah, see, vec pattern refers to C829, this location in memory. So anyway, when using draw pattern VL or draw pat VLD, the number of vectors to draw -1 must be specified in C823. When using draw pat VLA, the number of vectors to draw -1 must be passed in the A register, which is what we saw is actually happening for us above. And the vector list pointed to by the X register has the following format. So relative Y, relative X, relative Y, relative X. Draw pattern VLD starts at XY coordinates specified in the D register and ignores the first pair of coordinates in the vector list. Interesting. So I guess this could have also been used in our case, but it wasn't. Okay, so my plan is to get to the point where this kind of stuff's gonna happen. So over here, no, sorry, here. I want to get to this instruction, and then we're gonna step, and we should see that, like for example, executing this bit of code should get our cursor, our current position, to -4264. So that's, ideally that's where we should be by the time we've executed this function. So let's see if that's actually happening, and if it's not, why not? And in fact, there was something I was thinking about, and I think it had to do with the 0 enabled here. So before I do that, I just want to look at this again, because I think I'm not doing it right. What I've done is that I know that when we write to the peripheral control, that will set up whether we want a blank or not, and it also sets up whether we want a 0. But the thing is, zeroing is not just like a reset on the position. It's actually a state, meaning that while we're in 0 state, we can't draw until the 0 state is no longer enabled. So that's something I was reading, and I just wanted to make sure I do that correctly. So before I jump into the debugging, let me just take a look at my notes here. Bring this here. Zero enabled. When enabled, moves beam to 0, 0. And in fact, it's supposed to move the beam slowly to 0, 0, which is something I'm not doing. was just thinking about how to do that. I think the way I should be doing that, now that I've got like the correct code for cycle-based movement in my update here, is to say, let's see here. What would be the correct way to do this? I guess the way to do this is to basically compute the vector from where I am now, 2, 0, 0, and move there based on the current timer. And I guess we assume, I guess one way to do this is to assume that it would move there as quickly as possible. So that's probably the right thing. I'm just trying to think like, yeah, that would be like the right way to emulate it. What I can do as kind of like a temporary hack is to go something like this. If integrators are enabled, because I think you need to do both, right? You need to I was gonna say you need to have the integrators enabled and the zeroing enabled, but actually I'm not sure if that's true. Let me check. This information, I have it in here, I think, in the famous internal.txt. 0. Connected to the integrators that form part of the vector drawing hardware. This line will cause them to be zeroed, both x and y, and has the effect of bringing the beam back to the center of the CRT. It is an active low signal. See vector hardware section. I will. Okay, here. This line is connected to the 6522 CA2 line. As with ramp, it is an active low signal. During any integration operation, this line must be set to inactive during any integration. When active, this line will cause the integrator output to be set to 0 volts, which will be the center of the screen. This line should be activated before any line drawing sequence to set the integrator to a known value. Right, when they say the integrator output, what they mean is what do they mean? Let's see here. The integrator output value is held by a small capacitor. And this will leak charge. Basically, the result is that over a period of time when the integrator is not in ramp mode, its output will slowly fall to 0. So after drawing a sequence of vectors, it is best to zero the output to give a solid reference. I guess what I'm a bit unsure about is what they mean by the integrator output will be set to 0 volts, because from what I understand, basically you want to have the integrators, the output for the integrators is supposed to be the value that drives the beam, and if it's 0, doesn't that mean it doesn't move? Oh, I see. Okay, when they mean 0 volts, they mean, right, okay, it's the output of the integration, which is the voltage required to keep the beam at a certain position. That's what it means. Basically, if the voltage is 0, 0, that means that the beam comes back to center. To keep it at certain locations, it needs to set the voltage. And it does that over time, and that's how it ends up drawing a line. Okay, I understand. All right, fair enough. So in terms of emulating this, I think the right way is to assume maximum speed, maximum strength in X and Y, and to bring the beam towards 0, 0 in the center at that speed, in terms of kind of like mimicking the movement of the beam coming back. Because I suspect, like, if a program said, oh, I want to zero the beam, and it starts to come to the center, and then it says, no, I want to turn it on and start moving it somewhere else, and stop zeroing it, you would get some kind of like, if the beam was in the corner, it wouldn't quite reach 0, and then it would start to move somewhere else. And I don't know, I don't think any games take advantage of that, but in terms of being correct, that's sort of what we want to emulate. But the thing I was really interested in was whether or not we zero while ramp is active. Set the blank to that, set the 0 bit to 0 to clear the integrators. Set the ramp bit to 1. Then set the 0 bit back to 1 to disable zeroing. So yeah, so here what it's saying is that we expect that for zeroing to actually happen, the ramp should already have been enabled. Even though this code is a bit screwy, I think that's what it means. Because here it says set the ramp bit to 1 to disable, I guess assuming that it had been at 0 in order for the zeroing to actually do something. Or maybe not, maybe it means set this, set the ramp bit to 1 so that actually does the trick of getting it to 0. Yeah, it's very difficult to know what this means. Let me see here. Hey ABD CW. Thanks for joining. Actually, you know what? A place that might tell me the answer is in here. Or is this just about timers? Okay, what I'm gonna do is I'm gonna assume that the integrator needs to be enabled, and we'll see if that makes sense. And I'll put a little check there, a little reminder to see if that's really what we want. So is so if the 0 is enabled here, then we'll do the kind of positioning. And here I'll put to do move beam towards 0, 0 over time. And another to do, do integrators need to be enabled for zeroing to work. So I guess we'll see about that. Now, if we do the zeroing here, we don't want to do the rest. Okay, so let's say it's like this for now. All right, so let's see where this gets us. And also to make debugging this a bit easier, I have this this hack right now for allow drawing set to false. And what I'll do is when I hit my breakpoint and we'll start debugging, I'll turn it on so that we don't get like drawing beforehand for the font and text stuff messing up the screen. All right, so again, our goal is to see if we get these lines, and if we're not, why not? We're trying to draw this. I should have written Vectrex. I think it might have even written all these lines here, but we're going to focus on the outer boxes here and the inner box here and seeing whether our beam actually moves, because that's just a nice simple square to draw. Okay? And like I said, these are the actual coordinates and offsets that are passed to the beam. So let's check that out. Let's start this up. Okay, so first things first, we need to set a breakpoint, or run anyway, until a specific line. So that line, that's going to be here at F055. I'm just going to set up my input here. So what we're going to do is we're going to do load symbols. We're going to go into color, and we're going to say run until this address. Okay? And here we go. And why did I get this? Ah, right. Interesting. Interesting. Yeah. Yeah, so I'm hitting in this assertion because the bits in here have not been set correctly because we just initialized. So that makes sense that we're not quite in the right place. So maybe what we should do is we should enable, I'm not sure what the right thing to do is. Either we initialize port B so that ramp is disabled until it gets enabled, which probably makes sense. Yeah, let's do that. Let's initialize B to ramp disabled. Let's do like this. And port B, ramp disabled to true. Okay. So now what should happen is we won't actually enter into this loop until the ramp actually is enabled or not disabled. Okay, so back to this. Right, not good enough. Okay. Maybe the problem here is I shouldn't be checking this assert in here, but rather when we set the peripheral control value. I think that would make more sense. And same thing for isBlank enabled. I used to do that, but yeah, I need to read the bits with shift. Annoying. It's all right. We'll fix this correctly. I don't know what the clean way to do this is. Oh, right. Okay. And we'll do the same thing here. It's not amazing, but it'll be fine. These are just checks, so it's fine. I just want to make sure that when we're writing a value into this register that it fits the form that we expect. But it's only really on write that I care, not every time we access these functions. What it means is that when we ask these functions initially, if values are enabled or not, you know, it won't be valid. It'll return whatever garbage, because I don't think these registers are initialized, you know, in terms of hardware to valid values, but the BIOS initializes them early on, and then it's good for the rest of the time. So let's try that again. Make this a bit wider. And I'm letting it run with the color and all that. It's a bit slower, but I know that we should get to our instruction fairly soon. And I just like to have the history in there. There we go. So see, we just returned from some code before. In fact, from reset 0 ref. So technically, we should be at 0, 0 right now. Technically. Right? Because, and I say that, because so the control register is the one that ends in C. So D00C. So is that something that got written to here? Reset 0 ref. There. See, the very first thing here is store the value in B to the control register here. And the value in B is here, A and B, so CC. So C and C would be written there. And that corresponds to what? To 110. So 110 means 0 is enabled. So see, that sets the zeroing, and it also sets the blanking, meaning I don't want to see anything while we zero, right? So, and then after that, assuming we went through my code, I guess I could have put a breakpoint here and seen if we get the zeroings, but we'll see. We'll see on the next step if we are indeed at 0, 0. Let me go into update. So I'll just put a breakpoint right here. And we are going to just go and load into X the address of intro boxes. So I'm just going to step this, and we should hit our breakpoint in our update here. So step. And we didn't hit the breakpoint. Why not? That's weird. Because every time we execute an instruction, we're supposed to also update the via. Oh, interesting. My debugger doesn't do the same thing everywhere because my execute instruction only here calls update, so that's wrong. This is a debugging problem though, not a general problem, so let me just fix that. So execute here, Then update, here I'll put elapsed cycles like I had done before, and then return the elapsed cycles. I mean, I don't know. I don't know if this is the right thing, but we'll say it's good enough for now. I'm just saying that because, I mean, I'm not really just executing an instruction anymore, right? But it's okay. I'm simulating the execution of instruction, which also updates the via for that number of cycles. All right. Let's do this again. Actually, I'm just going to disable color. It's going to go a lot faster. There we go. Turn on color now. And now I'm going to put my breakpoint here. And when I step, there we go. We enter in here with a certain number of cycles. And let's check what our position is. There you go, 0, 0. So that's good. That means that the zeroing that was done just before this did the right thing. So I'm going to disable this breakpoint now. All right. So let's look again at our assembly instructions here. So this function should move our beam to minus 4264. So why don't we just go for like let's not step through all of it just yet. Let's just see when we reach this instruction. And then we'll see if our position is there. And if it's not, then we'll restart and we'll debug that case and see why not. So I want to run until F05B. Okay, there we go. And it's interesting actually, because here what you're seeing, when you see this pattern here, bit B, 0D here, checking the interrupt flag, this is basically it's saying I'm waiting for the timer to have elapsed. And when it finally gets here, it means, oh, the timer did elapse. Yeah, exactly. So move to IXFF, just executed, and we're done with that function. So now let's see. If I put a breakpoint in here and we step one more instruction, what is our position? X is 214.64. That does not sound right. So 64 is correct. So the 214, that has to do with sign wraparound. Okay, that's really interesting. Yeah, okay, because I'm storing the value directly into a float. But what I need to do is I need to make it shifted into the negative 128 to 127 range. Aha. See right there? We found a problem. So you see it has to do with this here. When we store into velocity, the velocity is actually basically a vector 2 of floats. But what we really want to store in here is a signed value. Because this is actually unsigned. So I think then all I need to do is cast to an int 8t, and then that will be converted into a float. Same thing here. Vector brightness, no. And then we'll see for the sound stuff later. But also the XY offset, I remember, is a signed value, strangely. Okay, so let's see now what happens. Turn off color. color. And then we had said actually that we'd run till F05B. Until F05B. Okay, and now we'll step. And let's see. Oh, it did not work. Why did that work? Okay. Let's see why that didn't work. So get here. Color is enabled. So before we continue, I'm gonna set a breakpoint where our velocity is getting set and see what's happening in code. Oh, yeah, I didn't do it for the X. And it's actually the X that's the problem. Okay, there, that explains it. I knew I was missing something. There. Okay, once again, set our breakpoints, step, and we are, oh right, we're at 0 right now, because I need to set my breakpoint to the next location, which is F05B. Okay, re-enable breakpoint, step. Alright, so that's not good. We got 0, 0 here. That makes sense? Actually, no, it doesn't make sense. Okay, so something's not working. Want to see here. We disable these for a second. Okay, we should be at 0, so now I'll turn on these breakpoints. Because I want to see what happens when we try to write those values. The next one is, was it 05D, I think it was? No, 05B. Okay, here. So we want to store 40 into X, which I think makes sense. Or does it? Yeah, I think it does. 40 I think is 64. Yeah, 64. Into X? Oh yeah, right, because it always outputs to the X register. So anyway, let's see what happens here. We have 64 here, we should get 64 in here. And we do. Okay, and there we just got D6. Just looking here at the code. Store B to port A. Port A has D6. Which is 214. So let's see if this does the right thing. So, I mean, casting this, yeah, it should be minus 42. And indeed it is. Interesting. That's odd. I didn't hit these breakpoints. Okay, load into D the value at X and then move X forward by 2. So that means that at D means both A and B now should have those 2 coordinates. And store A would have stored the first one. Then clearing here, so that's to store the Y value. Clearing would have disabled the mux. So why didn't we get these, hit these breakpoints? Oh, it's because I had this one disabled. Okay. So let's see. The position hasn't changed yet, but it's not position I was looking at, it's velocity. I'm an idiot. Okay, there we go. Velocity is minus 42 and then 64. Okay, okay. So that's good. That's really good. Really good. So this means that things are actually working with those casts in there. So now, let's again go for the gold. We want to go into draw pattern VLA. So we're going to end up in this code, right? Now let's let it do all the stuff here up until it loads the pattern into the shift register. So let's actually stop right there and see. Let me see here. Send Y, enable mux, point and X coordinate pair, disable mux, send X. So then by the time we get here, our velocity should have been set up for the next pair, the next movement. So we should be here, and we're going to set up the velocity to be at 86.0 in XY. Okay, that's cool. So let's see if that's actually what happens. Just thinking what the best way to debug this. Put a breakpoint here. We'll check if the shift pattern gets set when we store here. Then we do the timer. Note wasted byte. Update pattern if not. Oh, that's really cool. Because this is what they do. They keep changing the pattern. That's why the pattern moves. Looks like it's moving, you know? Like if we look at that video here. Mac10688 asks, am I reverse engineering something? I guess sort of. What I'm doing is I'm reading this Vectrex BIOS code here, and my emulator is actually executing this code, and we're trying to see if or why it's not rendering the lines for that you see here. So this is what the Vectrex, you know, intro screen should look like, and my code hopefully will render something like this. So that's what I'm trying to debug and figure out. Oh, thanks. I think I just saw that someone followed me. Oh, that was you, Mac, and also 3. So I got 3 red Rex3 who followed me, and Mac10688. Now for some reason that didn't show up on my OBS thing here. For some reason I have a Streamlabs alert box here that's supposed to do something when I get people following me. So I'll have to look at that. But thanks guys for the follows. Really appreciate it. The only reason I know is because I saw that I got an email notification for that. Okay, so what? Go back if more lines to draw. LF433, which, okay, yeah, then it jumps back here. All right, so let's put our breakpoint on F448. Just take note of that. Stop in draw pattern VL. About to set shift register. All right. So we go back to our debugger here. Actually, I need to hit F5. Okay, run until there. To disable more breakpoints. Okay, so now we're on the instruction that's about to set the shift register, right? So let's see if that actually works correctly. So I should hit this breakpoint here, and we do. And what does this look like? Shift looks like 1110, then 0000. Okay, that's cool. So I'm happy about that. Next, we've set our shift. So we just did this here. Next, clear the timer. So this here is supposed to start the timer. Check if it's timed out, and if not, interestingly, it jumps down here. Oh yeah, that's because of the pattern update. Normally we kind of do this infinite loop. I mean, with loop, I mean until the timer times out, but here they want to keep updating the pattern. So it'll actually jump down here, update pattern register. So store the pattern, wait a moment, check if timed out, update pattern again. If not, actually, why do they keep updating the pattern to the same value? That's so strange. Update pattern register. Check if timed out. Update pattern again if not. What I expected to see was that the pattern itself would somehow get modified, but it just keeps getting the default pattern. Get default. Unless what I'm thinking about is, like, if you set a pattern and then draw a line, the pattern won't move. It'll just kind of draw that pattern in its fixed location. But maybe by constantly setting the pattern at certain cycle intervals here, it ends up kind of like making it look like it's moving. If that makes any sense. I'm not sure. It doesn't make that much sense. In any case, I don't care too much about the pattern right now. I'll worry about that after. What I want to see is here. When we get to the line counter here, that means that the timer has timed out and we should have gotten our first line. Okay? So, and another thing I realized is I actually did not turn on the drawing hack, so I need to do that. But the next place to run to is 463. Stop. Yeah. After drawing one line. So that's what this means. So let's do that. And let me just put a breakpoint in an update here. Okay. And the hack I want to turn on right now is allow drawing. Oh, I need to actually get in here. And there we are. 1. So at least we're allowed to draw. Now, will we actually draw? Not yet. And there we go. Now we're drawing. Branch if you bit B via interrupt flag. We're checking. Blank is no longer set. We have brightness, and we're drawing a line. What does our velocity look like? Yeah, -42, -128. Signed, yeah, that's good. 3 cycles. Why is my delta 0? -9.14. Oh, I see my friend Mr. Castroman started watching. Hey, Alvaro. -1 here. How did this become 0, 0? Signed velocity. I don't need to check if it's greater than 0. I need to check if it is not equal to 0. Now that they're negative, they're not moving in the negative direction. Okay. Okay, so now I'm like kind of tempted to see if it just works. So now we're here. I want to go there. I want to set this allow drawing hack to true. Okay, and now we're going to stop after drawing one line. Well, I did not see a line get drawn. Despite the fact that I have lines here. This does not look right. So how you doing, Alvaro? So how did I get these values? So what we'll do, start again. Okay, we'll get here. Alvaro says he's doing good. Project looks interesting. Yeah, thanks. Actually, it's really, yeah, it is fun. Having a lot of fun with this one. It's cool to learn about vector graphics. Okay, so drawing is enabled. So we're just about to draw the first line here. So let's see what happens in here. Okay. So velocity is 86.0. Okay, so that should account for this. Let me bring it up again. Here. So 86.0 means I should be at minus 42.64, and I am not. Why am I at minus 337? Okay, so actually I'm not getting into the right position with the initial movement. So let me back up a bit here. Let's go back. I thought I had checked this. This movement right here, F058, move to IXFF. That's supposed to like actually move us to that initial location. Why isn't it moving us there? And I thought I had checked this before. What did I change? I would have messed that up. The sign? Okay, so let's debug it. So All right, start again. Just glad I have this debugger. It'd be like impossible to understand what's going on otherwise. Okay, then I'm going to move to here. That was kind of fast. Oh, because I stopped at F055, so I was right before there. All right. All right, so we loaded X there. Now we're here, and we're about to jump. So this move function should have moved us to the right place. So that puts into D the YX we want to move to. We should be setting our velocities here. Blank low, 0 high. Then shift, clear the shift register so we don't actually draw. Disable the mux, store X, store 1, get back the D register. Okay, so let's stop right here, F3 to 4. And now let's see what this looks like. Minus 4264. So that's that. The velocity is correct. My position is already on its way there. Does that make sense? I suppose it does, because I think we, yeah, 2 instructions earlier we said go ahead and start. See here, when we cleared the timer 1 counter high, that actually starts the timer, which means we're going to start moving our beam. Well, actually, that's not what starts moving our beam. That just is what stops moving our beam. This here, when we stored CE into the control register, CE. (110) and 111. So I think that if we come back to our control, so 110, 111, right? Here we go. 110 means blank goes low, which means we don't want to draw. We don't want to actually see anything, so that overrides the drawing. And then 111 unsets 0. So yeah, so it's from that instruction that we actually will start the beam. Does that make sense? I suppose so. sense? Does it make sense? Okay, I'm tempted to kind of start again because I want to see that our position actually is 0, 0 before we do this. I kind of went too far. Where am I now? F324. Yeah, F324 is here. I should have gone to F31A instead. Okay. Start again. And so now let's run until F31A instead. Now we'll turn this on again and let's just step and see where we're at. Okay, yeah, position is 0, 0. So that's the thing. Velocity is not cleared yet, but I suspect that we're going to end up drawing now. See, integrators are enabled. We're not zeroing, but our velocity is 64, 64. So that's not quite what I think is expected here when we come here. Bit surprised. What I'm surprised about is normally I would expect that we would write our x, y, like our y and x values and everything, and only turn on the drawing afterwards. But this actually turns on drawing before. See, blank low is 0 high is correct. I wonder if that question mark was also because whoever commented this was surprised to see it that way. Because when you do that, the vector hardware, I mean, assuming it starts running right away, would start moving the beam towards whatever stale values were left in those registers. Like in my case, we have a velocity of 64, 64. That's been left over. From where, actually? No, so we stored y. Okay, that's where the 64 comes from. It comes from this. See, y was stored and y got the value 64, which is here. And then we enable the mux so that the y gets that value. But whenever we write to the DA register here, the DAC, which is port A, whatever you write here also ends up in X. So this actually writes to both Y and X. And then you need to disable the mux to write the next value, like, so that the next value you write only ends up in X and not in anything else. That's why it's always this order. It's always first write to Y, then later write to X by disabling the mux. But in between the two, it goes and does this blank low 0 high. And you know what? Huh. This may have been done on purpose to compensate for how many cycles it might take before the zeroing is turned high, like before the beam actually starts to move. And maybe what they did, because you know it's the GCE guys who wrote this code, maybe they were thinking we do this, and then the cycles it takes to get to here, although that seems like quite a lot of cycles. It can't be that many cycles. I think all I saw was like it takes maybe 2 cycles. This is definitely a lot more than 2 cycles. I wonder if, did I miss something about how it works in terms of the timer? Does drawing only really start when the timer is set? Yes, it does. Yes, it does. Oh, yeah. Yes. The timer will set the blank. No, the ramp. Okay, the ramp should be disabled. The ramp should be disabled. Ramp should be disabled, and then when we start the timer, the ramp should become enabled. So why is my ramp currently enabled? That's the question. So let me see if I'm right here. Move to D. Oh, I gotta go back to here. Draw frame box. If I'm not mistaken, RAM should be disabled. What would disable ramp here? Because move to IXFF here definitely has to turn on the ramp to get things to move. Oh, sorry, it's actually, this is the function we're debugging right now. If I go a little higher here, no, there's nothing here. Does writing to low reset the ramp? Let me go check my timer again. I'm sure this is related to that. This PB7 flag. Okay, so the PB7 flag is set through 0xb, which is the auxiliary control. D00B here. PB7 enabled. Reset 0 ref. So I see that basically printing strings, which is something that happens before we draw our box. I think this guy is expected to, when it's done, to disable the ramp. Let me see. Print string. Jump to reset 0 ref. This function reset 0 ref is an important one. It gets called in a lot of places, and I think it's usually used at the end of a function because it does some resetting of the integrators and turning off the ramp, and then does an RTS. So rather than the function doing a return from subroutine, it uses this function to kind of like do the epilogue that it wants in a lot of its routines, followed by an RTS. Yeah, so you see, like, this is reset 0 ref. This routine zeroes the integrators and resets the pen back to origin. It leaves integrators in 0 mode, so nothing can be drawn until a move is done. Or D00C is set to 0xC to bring 0 high. This routine must be called every so often to prevent your vectors from getting out of whack. So it's in here that I wanted to see. So yeah, it sets blank and 0 to low, clears a shift register, then it comes to reset pen, clears the DA register, stores that into the, disables the mux, stores that to B, into Y, into X, and then disables the mux again. But see, that does not touch the ramp, which is what I was hoping to see. PP7. Like, one thing I also know is that in print string, it doesn't use the timer. So it disables the timer 1, like controlling PP7 here, so that it can do its own timing stuff, which is what makes this printing string stuff quite complex, which is why I didn't want to debug it first. But see, at the very end, it turns it back on. So it turns on T1 PP7 enabled. So that connects the timer 1 to that. Unless this not only turns on the PP7, but internally pulls it low. I mean, like, enables the fact that the timer 1 can write to PP7, but maybe that also is supposed to kind of disable the output, you know, so that ramp isn't on. So confusing because it's all inverse logic, but let me see here. See, we just set the flag here. PP7 flag. Yeah, okay. A single negative pulse on PP7 pin with the output enabled, a write, will cause PP7 to go low. Yeah, maybe that's the thing. T1 interrupt flag will be set. The IRQ pin will go low, and the signal on PP7 will go high. Yeah, I think I'm not doing this part right. And this is probably the reason why it's not working as expected. My guess is PB7, which is connected to the ramp, is not in the right state. Let me see. Yeah, look at this picture. When the timer has expired, PP7 should go back to high. Am I doing that? My timer should be expired. PP7 signal is low. If it's low, if the flag is set, so if it's enabled and it's low, this is not right. This is not, okay. This is not right. I think this is not right. I think what this should say is, in fact, if the PB flag is set, then always set the ramp disabled to what the signal is here. It's not an edge thing. It's not like when the flag is set and it's suddenly turned low, or while it's low, we set the bit. We need the bit to always represent the value of this. And that's the problem, actually. I've been thinking about how, like, does it make any sense anyway that I have this kind of redundancy, this bit in port B that represents the value in a timer. When I check this, I should just be checking this value in the timer. Is this working? Looks like I'm having some weird connection problems, I think. Are you guys? It says I'm streaming. For some reason I'm not connecting to my chat. I don't see the video preview. Let me try again to connect to the chat on the Twitch dashboard. I mean, it looks like I'm streaming. Oh, okay. I'm back on here. I don't think you guys lost me though, right? Let me know if anything cut out or looked weird. Okay, so I think this here should have been written this way. Does that make sense? Basically, I'm always going to check the PB7 flag. While it's on, I always want that value. Yeah. All right, so let's see what this gives us. Let's run here. So now we're there. Turn on color. And until here. Okay, let's put a little breakpoint in our update and let's step and see what this looks like. Ah, there we go. Integrators are not enabled. See, that's what I would have expected. Now let's see. Step. shift, mux, write the value, and there we go. By writing into the timer high, we start the timer. So this is good. And let's see, the velocity is now minus 4264. Great. Our position is whack. So that actually might answer my question about the zeroing having to do with having integrators enabled. So either I yank that out. I just want to make sure that I'm not crazy here. Let's go back to the reset 0 ref. That might answer some questions. Here. Blank 0 ends. So blank low and 0 low. Clear shift. Clear DA. See, like nothing here has to do with turning on the integrator, like with playing around with the ramp, which leads me to believe that pulling 0 low is like a massive override. In fact, I think I had a picture that could confirm that. Let me see here. Zero. See here, ramp messes with this, but 0 goes straight out to the integrators here. Yeah, so that right there I think answers the question. If 0 is set, it writes directly to the integrator outputs that drive the CRT, and it doesn't give a crap about this here, the SW. This has to do with the actual integration logic. And the ramp controls whether or not this outputs over here, but 0 overrides and writes directly. Okay, so that answers that question. So that means that this zeroing does not belong in here. See, that answers my question. Do integrators need to be enabled for zeroing to work? Nope. So we move this out here. This no longer is required. It's not required. Okay. Getting closer. We're getting much closer. It's exciting. Let me see if I can, I would love to set up OBS to capture the output of my, because the thing is I have this OpenGL window on my primary monitor. So either I like code it up so that it opens on the secondary monitor, or I can try here something. Let me see. Vectrexy. I don't know if this is going to work. I'll try and stick this up here. We'll see if that works. Keep my eye on that. What did I do with my chat? Okay, so you guys let me know if you see something weird. In the top right corner. Okay, so I got here. We're there. Turn on the update. I just want to see if I get zeroing. Why am I not able to set a breakpoint here? Okay. Sometimes my control key and alt key gets stuck on my keyboard. Integrators enabled like this. Okay. So let's step. Okay, so I just stepped and I got a zeroing call, which is good. So I think this is going to happen like over and over and over until zeroing is disabled. Okay, this here turned on the timer. So now we're in the position we expect. We're here, our position is 0, 0. Scorpion Illuminati says, make a Sonic Mania emulator. Sonic Mania? Why do you say that? And our velocity here, velocity is minus 4264. So that should bring us up here when all is said and done. So let's see this. Let's turn on drawing. You're joking? How you doing, Scorpion? Thanks for joining the stream. Man, for a moment I thought my stream had gone offline and I was like talking to myself. Because I looked over at the OBS dashboard and my video preview showed that I wasn't streaming. The chat was disconnected. I was like, oh crap. Like, have I been talking to myself for the last 10 minutes? But then I saw that there was that my network data was actually high. I was still connected in OBS, so it looked like it was just some weird Twitch dashboard thing.
Oh my god.
Dicks. Well, hello and welcome to Sonic Mania.
Woo! It's Sonic Mania.
We interrupt our regularly scheduled program of Sonic Unleashed to fucking.
All right, I'll watch that definitely later. Okay, so let's do this. So now, stop after drawing one line. So let's just go for the gold and see what happens. So have I ever had a Sega Genesis? I mean, I didn't have one, but I know a lot of people who did. My cousin had one, so I'd play with it when I went to his house. I know Sonic. I was a Super NES guy. I had a NES and a Super NES. So I had the crappier Mortal Kombat, as my cousin liked to remind me every time I saw him. So I think that OBS capturing this draw, no, it's fine. So you're a Nintendo fan? I guess you could say that. Yeah, I mean, I grew up with a NES. I mean, I was a kid when I got one, and yeah, I had a NES. I had a NES, Super NES, and a Game Boy. And as for the N64, by that point, my brother was old enough, and he asked for that, so he mostly played N64. And then by then, I was playing PlayStation, PS1 with my friends, because I was a bit older and kind of liked the games more. Not to say I didn't like N64, it was very cool. So I did not get a line drawn. So we are basically, after drawing one line, we are here. So let me put a breakpoint, and we're going to run again. Interesting. So where are we now? Position. Yeah. So we had the right position, we had the right velocity set up, but we moved too much. Like a lot too much. I wanted to move to minus 42.64, and we somehow ended up minus 965, minus 762. Okay, let's see why. Actually, you know what? I just want to try something. Oh, that's funky. You can kind of see like my other screen because it's capturing above it. That's so funky. The OBS window capture is a bit strange, so I'm gonna turn that off. Okay, yeah, so I'm not getting the lines. All right, so back to debugging this. So Scorpion asks me, how can you afford Beyond Compare's $60 price point? I mean, to be honest, I don't find it that expensive for the use I get out of it. I've been using it for years, and it's incredibly useful. The other question is, Alvaro asks, was your XY position on the same proportion as the expected position? That's a good question. That's a very good question. I'll check that. Yeah, that's a great question. I don't remember now what the values were, but I'll check. Scorpion says, if I'm doing open source projects, it's expensive for me. Yeah, I know. I mean, I work, right? So I make money programming for a living, and just after a while, I found myself, when I was at home, missing the tools that I use at work. And so I looked at Beyond Compare, and yeah, it was about $60, and I thought, okay, you know what? It's a good piece of software. It is, for me, leaps and bounds above the other compare software out there. So I decided it was worth spending on. It's just like Total Commander, this tool here, which I think a lot of people think I'm a freak for using, but I basically don't use Explorer anymore. I use this thing here because I just find it like so much better than Explorer. And I've gotten so much mileage out of this tool over the years that I just had to buy it. I was using it kind of illegally because it's like, shareware that's uncrippled. And at one point I was like, you know what, that's wrong. I gotta pay this person, this developer who made this awesome tool that I've been using for years and years. So, it's I guess more of an ideology thing, right? It's kind of like how, you'll spend like a couple $1,000s on your computer, to do your home projects, and you'll buy a good keyboard and a good chair and all that stuff, and why not spend some money on the software that you want to use every day? It's sort of the way I see it. Okay, so let's get back to the beginning of the draw and let's see what's actually happening. This is just before drawing. Scorpion says that he has a cheap PC. Well, I mean, you know, like I mean, this PC is actually pretty old, and I built it from parts, so I try to save money there. I'm not swimming in money here, right? I'm just regular employee, but you know, it's what you choose to invest in and all that. I mean, I don't know how old you are. I don't know what you're doing, if you're a student or not. When I was a student, I couldn't afford to buy my software and all that. It's just that I've not been a student for a little while. So I'm gonna run. Scorpion says I can't find a job. Are you because of your condition? I'm not sure I know what you mean. You'd rather not railroad my stream? Hey look, if you want to talk about it off stream or something, you know, we can. You know how to reach me? So it looks like I got another follower, the Divider 101. Thanks for the follow. And again, I'll have to check why Streamlabs is not showing an alert for that. I wonder if it's because it could be since the new extensions API for Twitch. So maybe, I know that I got an email from Streamlabs about using their new extension in Twitch, and I wonder if that kind of replaces the old stuff. And so maybe that's why it's not working anymore. I'll have to look into that. So, okay, so basically I'm at the point where I'm about to draw the first line. So what we could do is put a little breakpoint here again, and we'll run until F463. So here we are. Bit surprised. What? Am I wrong? I had stopped at F448 here. And I was about to clear here to start the timer. Oh no, this is too late. What I really wanted wasn't here. It's here. Okay, no. I'm losing my focus here. So it's the call that I wanted to see. F058. And then I wanted to run that and see. Okay, so let's start again. Next, we go until F058, which is actually like one more instruction. Now we put our breakpoint in here. Here we go. Okay, there we go. So 0, 0, and minus 4264. So actually, just for the record, I'm going to store F322, which is yeah, that's like when we're about to start moving to initial position. Start the timer. Oh, thanks, Scorpion. I'll, if you don't mind, I'll check the PM later and we can chat. So we're about to move. We're here. So this code that I wrote, I know I'm ignoring the offset, and I think that's because the offset's 0, so this should be no surprise there. There's my sign velocity. Aha. Yeah, it's interesting. Okay, I had set my velocity here to positive values on purpose. Now I ended up making them signed because I was actually taking care of subtracting minus 128 here. So why was this causing me a problem? Or was it just I thought it was a problem, but it wasn't. This explains why we're not moving correctly, because we're basically, see, sign velocity here is much too large. We were expecting to be moving at minus 42 and we're actually moving at minus 170. So that's the bug. My question here is, what's the, like, was this not what I should have done here? Because I was already turning this like positive value into signed values here. Yeah, I'm gonna undo those changes with the casts and go see what happens now. Maybe it's a combination of this with other fixes will do the right thing. Like because I prefer keeping these positive and then like doing the sign. Like I like to think about it as velocity is a bit of a misnomer, but it's more like I should probably rename that to like integrator strengths or something, and those are like directly the values that got written into the X and Y axis integrators, and then in here we take that in and we take it and we interpret it the way we want to for drawing purposes. This is the logic here. So I think this is more the correct way to do it. So Scorpion says, you never showed me your Vectrex. That is true. That is true. You know what? Maybe as a little bonus before the stream's over, if I have a bit of time, I'll go grab my box and just kind of show it. But I won't plug it and all that, but I'll just show you my box and take it out and show that I do indeed have one. But before that, I'm really excited to actually see some vectors drawn. I feel so close. Oh wow, there's a bunch of vectors that just got drawn on my display. And they do not look right. But this would be for like the font rendering. It's pretty nuts though. Does not bode well, but it's okay. One step at a time. So let's run until here. Oh, not actually to here. About to start moving to initial position. That's really what we cared about. Now let's put on our breakpoint here and step. Position is 0, 0. So see now our velocities are those larger values, sure, but then the sign velocity is 86 minus 64. $86 minus 64. What? Scorpion says, why not do a stream of you playing your Vectrex at 50 followers? I suppose I could. I guess I could do that, but to be honest, like, you just mean like total 50 followers? Where am I at now? I'm at 40 followers? I could do that. Okay, so what is going on here? $86 minus 64. The picture confuses me. Play minefield. Which picture? This picture? So this is a picture of what I'm expecting to happen for drawing the initial box. Yeah, so basically this here is supposed to be the screen. Okay, the Vectrex screen, which is logically a square. It ranges from minus 128 to 127 in X and minus 128 to 127 in Y. And the idea is that when we want to draw this box, I'll show you. See here, draw the frame boxes. So what I'm talking about there is these frame boxes. See, there are two of them, right? So the code that does that is right here in the BIOS, really early on. And no, it's not 0 to X. 0, 0 is the center of the screen. It's like Cartesian coordinates. And with 0, 0 in the center. And basically it wants to draw these intro boxes. And now intro boxes here is basically this array of offsets. So the idea is initially it'll go to 0, 0, and then you'll move 64 in Y minus 42 in X, which corresponds to here, 0, 0. So 64 in Y minus 42 in X, and that should put us here. Then after that, we start drawing, and you'll notice that everything after that are just offsets again. So, 0 in Y followed by 86 in X. So 86, 0 like that. That actually draws this, the stippled lines to here. And then minus 127, 0 means don't move in X but go down minus 127. Then 0 minus 87 means don't move in Y but go minus 87 here. And then move 126 in Y but don't move in X. So we go up here. And while we're doing that, we're drawing these kind of lines that are non-solid, stippled like this. And there are actually two of them. There's the inner box and the outer box, right? So this is the outer box and then the inner box here. So actually it's drawing this one here that we're hoping to see. So this is a fairly simple example to understand in the code. It happens really early, so that's why I'm debugging that. So I figure if I get that working, we're in pretty good shape. And it's something I can debug. Does that make sense now in this picture? So you're used to NES, Super NES, Genesis, which is 0 to X. Yeah, no problem. You know, I explained it at the start of the stream, but of course not everyone is here, so I don't mind re-explaining it. It's cool. All right, so my question is, where am I getting a value of 86 minus 64 from? The 86 to me would correspond to this here, but actually what we're supposed to be doing is moving up here. Let me look at the output here, the code. F322. Yeah, so this should be when we're about to do the initial move. So really what we should have in here is minus 4264. So Scorpion says, where is the BIOS disassembly? It's this here. So the BIOS source code was released by the company that made the Vectrex. And then somebody was nice enough to actually like look at it. Actually, no, sorry, the source code was not released. The BIOS itself, the ROM, was released with, you know, public license, which was really cool of the company. Like basically when they shut down their Vectrex, they were actually working on a Vectrex 2, but they shut it down because of the crash in 1982, the video games crash. So they decided, since they were going to stop doing it, rather than keep it all closed, they went and released everything. They released the designs, they released the ROMs, and they made it totally legal, which was really awesome, right? And somebody disassembled and went ahead and commented all the functions. So all of this here, you see here, that's somebody who went ahead and disassembled it. Now what I did is I took this version of the source, this assembly of the ROM, and I assembled it using an assembler and told it to generate a listing. So what that allowed me to do is to get addresses for every single instruction. So now it's really easy for me to cross-reference where I am in my emulator with the code that it's executing. Yeah, Vectrex 360. So this has been extremely useful for me, especially when implementing the CPU, and it continues to be useful. It's like having kind of like a debugger, right? I've got my source level debugger, not source level, sorry, CPU instruction level trace debugger here, and then using that I can do things like run until a specific address, which is what I'm doing, and I know what that actually means in the BIOS. Yeah, the Vectrex 2 looked really cool. It was some kind of color-based vector display. Okay, so let me focus on what the hell's going on here. Where can I get that commented code? You want to know where I got this code? I have a ton of links here for stuff, so I don't even remember which one of these led to that. Best site with lots of downloadable docs. It's probably this one here. Because for me, I've downloaded all of them. Yeah, so here there's a very good chance that it's in here. BIOS. So here's bios.asm, disassembled version. So that looks like, yeah, this is it. So if you want the direct link, even though it's in here, you should just post all your links. I guess I could do that. Like in on my Twitch stream, on the Twitch page, I could put a bunch of links for that I found. See, what I don't understand is here we did store B, where is it? Load A, CE, store A, 0C, clear, store B. So the B here, there. So this load D x++ should have loaded into D the initial values to set those the initial values we wanted to move, which should have been minus like 64, minus 42 in decimal. This would have been in A and this would have been in B, because they store YX all the time. Now storing A to 0, 1 here means we want to set Y in there. By clearing this, we enable the mux, which would get that value into the Y register. Push AB. So okay, so here we push the values in the D register. Then we load A with CE to store it into the control. And then we clear 0A, that means clear the shift register because we don't want to draw. Then by incrementing port B here, we disable the mux such that the next value, which is the X value that we wrote, ends up into the X register. So by the time we come to the clear 5 here, I'm expecting velocity to have those two values in them. Now I just undid the static casts. I know that's what I just did. And it surprises me that that would be no, wait, 64 and Y. Why am I getting confused here? 64 minus 42. Okay, yeah, so 64 is correct. Yeah, it's the minus 42 that I'm unsure about. So 214, of course. It's not minus 128. Yeah, okay, so it is a signed value. Yeah, basically it's more like a modulo 128, you know, an F mod that I want here. Yeah, Alvaro says, do you still need to apply the minus 128? No, I do not. Yeah, I guess that's it. It's not correct. So maybe what I had before made more sense. Storing the signed velocities in here. Okay, so let's do it that way. I think that makes more sense. Like, what I'm doing is a domain shift, but that's not correct, right? It's more of a wraparound because it's actually a signed value that wants to be stored into the registers. So it's either I do the cast here or I do the cast up here, you know? In which case, I guess I don't need signed velocity here. So either I like F mod here or something. All right, let's put back the cast here. So we'll have signed velocities already. So I don't really need the signed velocity stuff here. I'm gonna have to modify with the offset eventually. So we'll just put velocity here. So Scorpion says, so if the copyright is wrong, it will boot into Mindstorm. That is correct. Okay. About to start moving to initial position. So let's go there. So let's see now what this looks like. 0, 0. Velocity is minus 4264. Okay, so that's back to where we want it to be. Now this time, if we run until after drawing the first line, Scorpion says, will your emulator emulate that? It already does. It already does emulate that. Basically, if you don't put a cartridge in, it won't see the copyright text in the memory locations that correspond to the cartridge address space, and then it'll say, oh, there's no cart, and it'll jump to Mindstorm. So right now, like, I don't have a cart loaded, and it goes to Mindstorm, and if I put a cart in, it'll actually execute that code. We don't see anything, but it runs the code. Okay, so now I ostensibly moved and drew the first line, even though we don't see anything. Just a bit disconcerting, but it's okay. Let me see what my lines are looking like. Still crazy values. So no, not cool. No, Mindstorm is part of that ROM that was released along with the BIOS, because it's all one thing, and it's all it's open. Alright, so we ran here, moved to the starter line, about to move to the initial position. So let's do this again. Now, step. So the velocity is set correctly. Let's just step through here and just see what this looks like. So you see, we have 6 cycles that we're executing right now. 128 divided by this velocity. So I want to move. Does this make sense? Basically, from the way I understood it, it's supposed to move like one pixel per cycle at max velocity. Oh, so I think I have this ratio wrong. Yeah, this ratio is wrong. It should be this divided by 128. Alvaro says he's leaving. Thanks for the stream. Good luck with those vectors. Thanks, man. Thanks for hanging out. And I'll talk to you soon. I bet you're leaving just before I get the vectors working. And you'll be like, damn it. Holy shit. Alvaro, are you still there? Because I gotta show you this. Oh my god. Okay, hold on. Let me just, how the hell do I show this? Gotta get this window on this damn screen. Yeah, you know what I'll do? I'll take a screenshot. This is what my window looks like right now. Check it out. This like basically is some messy version of Vectrex, GCE, copyright, whatever. Like if I bring back this image here, it's not right yet, but holy crap, we're close, right? And I mean, and I know I've got timing stuff not correct just yet, but oh, this is pretty cool. So let's see if we get those boxes now. I see Solo Techno just followed me. Thanks for the follow. Really appreciate it. Oh man, this is so freaking cool. Okay, so let's go for the gold and see what happens with the boxes. So the thing is right now is my lines just draw and draw and draw and never stop drawing. Like I don't have any way to expire my lines or anything. So I'm just gonna run and I'm gonna move my window over to the screen and we're just gonna watch it become a big mess of lines. But that's fine. So let's go here. Let's turn off the trace. Actually, let's turn it on. Let's continue running and I'm gonna try and move my window. See if that works. No, that will not work. Okay, turn off the trace. Oh shit, I have lines. Okay, I gotta show you guys. Look. Look at that. Oh, man. I just like reset my... I accidentally clicked somewhere, so I don't know if anyone wrote in chat in the last 5 seconds, but Scorpion Illuminati says, it's too big! It is too big. But man, it's awesome. I'm not surprised at all at the fact that it's too big and that everything is kind of offset, because I know for a fact that I am not cycle accurate on when the line drawing is on or off. That ramp signal that determines when to turn it on and off is not cycle accurate just yet. So that would explain a lot of this discrepancy. But yeah, still a sweet victory, as Scorpion says. Absolutely. Holy crap, this is cool. I wasn't sure if I would see this. And now you see like my frame rate has dropped dramatically. Actually, let me try and release. With the release will go a bit further, a bit faster. So maybe we'll see lines for the actual game. Yeah, a lot faster. But see, the frame rate is going to drop dramatically because the number of lines that are being added just keep growing and growing and growing. So what I need to do is I need to make my lines expire. I mean, ultimately what I need to be doing is not drawing lines like this. This is like a my quick and dirty solution to just getting lines on screen, where I just like make a big vector of lines. But what I need to really be doing is drawing into a buffer, a pixel buffer, and that the pixels have like a lifetime associated. So like another buffer, which is like the time at which the phosphor, the pixel was written, so that I can make it fade away over time, like a real screen would do, a real vector screen. And then that way I don't have to have this huge list of lines, I'm just drawing directly into a buffer. But this was just a much faster way to get things working, right? Some OpenGL GL line drawing. Yeah, this is very, very cool. So what I'm going to do here, I'm going to get this cleaned up and checked in, and Scorpion says I should quit my day job and sell emulators for a living. I don't think people will pay me enough money to do that. But thanks. So let's see what my changes look like. I think there's been quite a few changes in here. Yeah. There's also this thing in my debugger. So let's check this one in first. So this is debugger. Make sure to update via when executing instruction. Sorry, when stepping instructions. So that's what that fixes. Okay. And this is just a boatload of fixes for getting drawing to start working. Yeah, so pretty convinced that that's right. That's gone. To do, yeah. So I'm gonna get rid of my hack here because now I don't need it anymore. So many things in here. Oh yeah, clean that up. App address. Yeah. Okay. No, this is gone now. Okay. Make sure that builds again. Okay, this works. So let's get this committed. So I'm just going to say here via bunch of fixes to get basic vector drawing working. Timing is off. I'll just say vectors draw, but are definitely off, likely due to ramp timing. So ramp setting not being cycle accurate. And what else I want to say here? Also, very much need to clear lines, make lines expire for some time. So commit, and I'll push these changes upstream. So if anyone's interested, you can take a look. Scorpion says, No Cash GBA used to sell a debugger version of their emulator for $100 for indies with basic features and $699 for a full-featured version until someone cracked it. Then he got pissed and stopped working on it. Yeah, I totally remember that. And you know, I think that was at a time when people were interested in doing a lot of homebrew for the Game Boy Advance. Less interesting, I guess, for the Vectrex. I know there are people that are doing homebrew and they'd be happy to have some cool tools, but I mean, I'm not going to make enough money on that to warrant even trying. To be honest, I'm more than happy to do this open source. So normally I would sign off here, but Scorpion, you asked me if I could show you my Vectrex. So I'm just gonna go grab my box and I'm just gonna put it on camera, and at least you'll see that it exists. I'll be right back. So let me take a look at what this looks like on OBS. Okay, so you can't see anything. So I'll move my camera down a bit. Okay. So this is my Vectrex box. Okay, you can see that it's a little beat up. Okay, so there's the box. I have a nice garbage bag on the top. It actually still has the flaps on the top of the box. And here is the Vectrex itself. So let me see if you guys can see that. So that's the Vectrex. So it has this very handy little handle here, although it's a bit heavy. It's got the really cool joystick thing here that's a bit hard to open when it's not lying flat, so I'm not going to bother. And what I'll show you are my games, which I have neatly put into a Ziploc bag here. Actually, they're upside down. So these are my games. And then behind the games are the overlays that come with the games. Because these add color. So yeah, I'll go like this. And so here you have like that's Hyper Chase, which is a racing game. This is for Ripoff. It's a really cool game too. Berserk. Scramble. That's for Blitz. Clean Sweep. And Star Trek. So those are the screens I have. I'm actually missing one for Mindstorm. which would have come with the Vectrex, and I don't know what happened to it. So yeah, so I have one for all the games I have, except for Mindstorm, the built-in one. Put that back up. So like, I will do a stream where I'll try to hook up a camera or something and I'll play a little bit. There. Things to the side. Okay. So there you go. So it's a real thing. Scorpion says, thanks for showing me, can't wait till 50 follows. It's my pleasure, man. I'm in really good mood because just getting that vector drawing stuff working was my ultimate goal for the night. So, or it's actually been my ultimate goal for like a few streams. So I'm super glad that worked out. So yeah, I think I'm gonna call it quits here. So guys, thanks so much for hanging out, and I should be back online. I should be back live next Monday. So yeah, thanks for hanging out, guys, and I'll catch you next time.